So what we're going to do in example one, now we're getting into what's known as segment addition. And segment addition, believe it or not, well, first off, we're going to cover this today, right? And in this section. But the principles that I outlined here, we are also going to do next week or the week after when we get into angle addition. Right? And then in a couple of months, probably around the end of October, early November, we're going to cover it again when we get into triangles. And we are going to do angle addition in the construct of a triangle. And then once we get done with that, a little further on in the year, we are going to cover these same principles again in the construct of quadrilaterals. And we will use them again to solve problems and to prove what type of quadrilateral they are, both with angle addition and with angle addition. And we're going to keep going on this over and over and over and over again. And literally, probably the last lesson that we will actually do in here, our last instructional day at the end of the school year, we will probably still be using the same principles. And when I lay these out, you guys will roll your eyes. But when you roll your eyes, just remember, today, last day of the first week, when I laid these out, I said our last lesson we were going to use them. Okay? So, what we're doing is we're doing angle addition. Segment addition. And segment addition is, there's four main principles to it. Okay? There's four main strategies. All right. The first strategy is part plus part equals whole. The second strategy is part equals part. The third strategy is whole equals, I screwed this up yesterday. Whole minus part equals part. And finally, whole equals whole. Now, when you are solving segment addition problems, you're not going to use all four of these strategies every time. Sometimes you may only, in your simpler problems, you're only going to use one. Right? More complex problems, you're going to have to use multiple of these. Okay? But I'm getting ahead of myself. Whenever we're solving problems, the first thing that we want to do is read the problem. Okay? Reading is huge. Now, I don't know how you guys did on your keystones. I haven't had a chance to look at that data yet. However, the biggest issue that students have on keystones, they don't read the problem. The biggest issue people have in life, they don't read the fine print. They don't read anything. You gotta read. All right. I wish I could tell you that there's some kind of magic bullet that all of a sudden you just know what's going on. No. All right. I am not a car guy. All right. I don't know if I told you that. My father is an excellent man. I love him deeply. He has been very successful. However, one of his weak points is he does not have a lot of patience, and he does not like cars. All right. And so when we worked on cars, and we worked on cars a lot when I was a kid, there normally was a lot of screaming, a lot of yelling, a lot of cursing, and as a result, I don't like working on cars. All right. However, at some point, economic realities hit, and I have to work on cars, right? Thankfully, YouTube exists, and I learn a lot. However, I watch a video and I'm like, I don't know what they're talking about. They just used the word, I don't know what that is. Guess what I have to do? I have to look it up. All right? Reading is an active process. It is not a passive process. And so when you are reading, you should also be thinking. And if you don't understand what they're saying, you have to stop. And you have to say, okay, what is being said here? Right? It's not pretty, it's not easy. Anybody that tells you that is blowing smoke in your ear. Don't listen to them. All right? So, first off, we're going to read. Second off, we're going to think. Lastly, we are going to act. Okay? Now, there are some steps to acting. Okay? Acting, I don't mean saying. I mean do. Yes? All right. So, the first step is to make a drawing. We have a drawing here right now. However, we need to add some things to it. And so I'm just going to add the points. J, K, and L. I think the points make that all much easier to see. So now we have a drawing. Right? Josiah, what does number 2 say? Yeah, we have to label this drawing. And so what we're going to do is right here it says JK equals 6R. So right here between J and K, I am going to put 6R on my drawing. Then it says KL equals 3R. And so right here between K and L, I'm going to put 3R. And lastly, it says JL equals 27. Now, since JL is this whole thing, I like to do one of those. I don't know what you call that thingy, but I like to do it because it tells me that that whole distance is 27. Now, all right, Quentin, do we have everything labeled? Yeah, we do. All right. So, can you read what number 3 says from all the way back there? A formula. All right. Yes. It's not written as large as I would like it. Yeah. So create a formula. Okay. Now, before we create a formula, we have to come up with a strategy. So, Dale, here are my 4 basic strategies. Which one do you think I'm going to use? The first one, part plus part equals whole. I will tell you guys, of the 4 strategies, the first one is the one that you are going to use most of the time. All right. Another one that you will use quite frequently, especially when we get into midpoints, is number 2, part equals part. Number 3, we're probably not going to use that often. If we have any type of variable inside, I would avoid that one and go with the first one. Just because whenever you have a minus, then we have to distribute the negative. It's a pain in the neck. Much easier to go with the number 1. All right. And lastly, whole equals whole. We'll use that at various points, believe it or not. Okay. Fine. Anyway, yeah, we're going with number 1. So, using a number 1 strategy, Hunter, and using the names of the segments, can you give me a formula for our problem? No. I want like JK. You want JK plus JL. And what does that equal? JL. Yeah. All right. Thank you very much. Believe it or not, that right there was the geometry that Hunter just did. coming up with a strategy, and then giving us the formula. That was the crux move. All right, you guys, do you know what the crux move means? That's the tough move. It comes out of climbing. All right, and typically in climbing, there's one move that's really nasty, and after you hit that, you kind of relax and you're like, all right, I can send this baby. All right, I can finish it. All right. At any rate, so now we have our formula. The next thing that we want to do is we want to substitute. Okay? And so, Annie, what does JK equal? Right. So all I'm going to do is put 6R here, and then what's KL equal? 3R. And so I'm going to substitute that, and what does JL equal? 27. All right. Couple of things. You may have said, well, Mr. Barr, we could have gotten all that just from the problem. Why did we have to label it? By labeling it, it helps us to see. Okay? And that also allows us to physically put our fingers on our drawings. And the more senses that we can use to help us solve problems, the better. All right? Okay? And so if we can put it here and we can physically see it, and then we can touch it, all right? We're using our senses to help us solve problems. Yeah? Groovy. All right. Like I said, now the tough part is done. Now it's just algebra. All right? Charlie, what do I want to do now? Okay, and how am I going to do that? Right, but right here, right now, what do I want to do? 6 plus 3. Yeah, I'm going to combine like terms, right? And 6R plus 3R is what? 9R. And so I have 9R equals 27. And then Tyler, what do I want to do next? Yeah, I'm just going to divide by 9. And so, what is 27 divided by 9? 3. All right. Molly, am I done? Am I? What do you think, Dale? Isaac's shaking his head no. Why aren't we done, Dale? Good, Emily. How did you know that we needed to do that? Yeah, you got to read, right? Determine each measurement. Remember, I started off with a 5-minute harangue on why you needed to read. We need to read. So, just like Emily said, yeah, we want to substitute in 3, 4, R in both JK equals 6R, and so we are going to go ahead and put in 6 for or R for 3, 3 for R, excuse me, and so JK ends up equaling 18. We are also going to do a similar thing with KL. KL equals 3R, and then we will go ahead and substitute in 3 for R, and so KL equals 9. And we already know that JL equals 27. Okay.